Now it's time to get to the heart of where we've been going with this talk of logic and reasoning, conditional statements, and that sort of thing. We want to investigate exactly how is this proof game played in mathematics. In mathematics, we prove things. In other words, here's what happens. We will be given definitions, theorems, postulates, properties, and we use those things that we accept to be true to prove things that we suspect to be true. Now remember, a postulate is, things like what I've shown you here. Like, for example, postulate 5, through any 2 points there exists exactly one line. These are things that we just accept to be true without proving them. Now, and you see I've got a whole list here just as example. If two planes intersect, then their intersection is a line. We just are going to take those as givens. Now, the thing is, some things are not just taken as given. Some things we require a proof, like theorems, like Pythagorean Theorem. In a right triangle, a squared plus b squared equals c squared. We require that to be proven. And once it's proven and it's accepted that it's proven, we call it a theorem. Okay, so it's something that's been proven. And we also have properties, but we use these things to prove things that we suspect to be true. So let me show you an example. Notice I've got some properties here, some algebraic properties of equality. Okay, so for example, if a equals b, then we could add c to both sides, and a plus b, or a plus c equals b plus c, that sort of thing. We have the subtraction property. We can a minus c equals b minus c if a equals b. Okay. If a equals b, then a times c equals b times c. So we've got these properties. And remember, we've got the distributive property. A times b plus c equals ab plus ac. In other words, we can distribute through here. This is the distributive property. Now, what I want to do is I want to show you how a basic proof can proceed. Okay, so look. Let's suppose that we have this statement, this one right here. Let's suppose we're told if 2 times x plus 5 equals 16, then x equals 3. And we want to prove that to be true. So here's kind of the structure of what we'll do. First of all, we'll write down 2 times x plus 5 equals 16. And this is given. Okay, so we're going to put over here a statement. And over here is a reason. Now, not all proofs are constructed like this. This is like a 2-column proof, right? We've got a statement, and then right beside it, we're given the reason. But this is the vehicle we're going to use. We're going to use a 2-column proof. So 2 times x plus 5 equals 16, that's given. Now, the next step, I'm going to clear my parentheses. 2x plus 10 equals 16. And that is the distributive property. And I'll just say distributive property. Okay. Now, we know how to solve this equation. But what we're doing is we're going through with a little rigor here. Okay. Now, the next thing I do is I take 2x equals 16 minus 10. And let me write that a little bit differently just to see what we're doing here. We got 2x plus 10 minus 10 equals 16 minus 10. So in other words, we subtracted 10 from both sides. And that is, look at this, the subtraction property. Okay. So this is the subtraction property of equality. Of equality. Okay. That's what that is. So now that we have that, we can do this. I've got the 2x equals 6 Okay. Now I want to divide by 2. Okay. And look at this. This is the division property of equality. Okay. So this is the division prop of equality. Okay. And therefore we have x equals 3, which is what we wanted to show. See? This is what we wanted to show. So at that point, we're done. And we have proven what we wanted to prove. Okay? So really, we just solved that equation, and we went about it, in a more rigorous way than usual, because we had to state our reason. And maybe when you were in Algebra 1, maybe your algebra teacher required you to state the reasons. Okay? But so we basically did that. And this is a 2-column proof. I guess sometimes people might call them a T proof or something like that. Okay, now let's look at one that's geometrical. Okay, so we've got some properties here that I'm going to refer to. I don't need to read them all out to you. You can, if you want, pause the video and read through these. But what I want to do is I want to play the same game that I played with that equation, but I want to use it in a geometrical situation. Okay, so let's look at this. We've got this figure over here, and notice that there's notice that angle 1 and angle 3 are equal. They've got the same measure, and that's what that little, we've got this little line here. That's what that means, that those two angles are the same. And what we want to do is we want to prove that angle EBA is equal in measure to angle DBC. That's what we want to do. So let's first of all just write what we know. Okay? So let's start off with what we're given. We know that the measure of angle 1 is equal to the measure of angle 3. And the reason for that is just given. Okay, so this over here is the statement, and here is the reason. Okay, the reason is it's given. Now, let's do this. Let's start seeing what we know here. Now, the angle EBA, let's just look at this. The measure of angle EBA, okay, so EBA is equal to the measure of angle 2 plus the measure of angle 3. Let's see if that's right. So I've got EBA. Yeah, the measure of angle 2 plus the measure of angle 3. And that is angle addition postulate. Remember that. We talked about that, angle addition. So this is the angle addition postulate. Okay, angle addition postulate. Okay. Okay, now we've got that. Now let's go to the next step. Let's see what else we can write. And remember, I'm working toward this goal. I'm trying to show that these two angles are equal. Now, here's what else we know. We know that angle EBA is equal to the measure of angle 2 plus the measure of angle 1. Now, how do we know that? Well, by substitution. So this is substitution. The substitution property of equality. You see that? So look, because up here, look, measure of angle 1 is equal to measure of angle 3. There's angle 3. So I just made that little substitution in there. That's all I did. Okay. Okay, now, we've got that. Now, enough of this EBA. Now let's go over there to the other angle. Let's talk about the measure of angle DBC. Well, the measure of angle DBC, let's see what that is. Okay, DBC. Well, we've got DBC. Well, that's equal to the measure of angle 1 plus the measure of angle 2. And this is angle addition. See that? Now, just take as long as you need to get a handle on that. Okay. Now, look at this. Here's where we land. The measure of EBA is equal to the measure of angle 1 plus the measure of angle 2, but so is the measure of angle DBC. Well, if that's the case, then we have the measure of angle EBA is equal to the measure of angle DBC. And I guess that we could call that transitive property, okay? And you can look back up in the properties that we've been given, but this is transitive property. Okay? Transitive property of equality, we can just say. Okay? Transitive property of equality. Guess I could go ahead and write it out. I've got room. Okay, so there is an example of a proof. We have the statements and we have the reason. So you get in your mind the path that you want to go and you just start writing. Now, to get the juices flowing, you just write down your given. And then you say, okay, well, what do I know immediately? You know, just write down what you know immediately, and you look for ways to prove what you're trying to prove, which was I was trying to prove those two angles are the same. Now let's look at another example here. Okay, so in this diagram here, this blue line, you're told that the measure of AB is equal to the measure of angle CD. And we want to prove that AC, the measure of AC, is equal to the measure of BD. That's what we want to show. Okay, now, so we're going to start this off. So we've got a statement, and we've got a reason. Okay, now the first thing is easy. I'm just going to say, well, AB equals CD. That's given. That's the only reason I need. That's what they told me. Okay? Now, you're thinking, okay, I've got to think of a way to get AC and BD together. I've got to think of a way to get those together. I've got AB and CD. I need AC and BD. Okay? I've got to figure out a way to get those together. Well, here's one thing. I know that AC is equal to the measure of, let's see here, AC is equal to AB plus BC. Okay? That's just segment addition. Postulate. I'll just write a segment addition. Okay? Okay, cool. Now, let's talk about BD. Okay? So let's talk about BD. So BD is equal to BC plus, okay, CD. Okay? Once again, segment addition. Yeah. Okay. Okay, now remember what we're trying to do. We're trying to show that AC is equal to BD. And we've got this thing. This is what we've got. Okay, so I need AC is equal to BD. So let's see if we can see what that is. First of all, AC is equal to AC is equal to AB plus BC. And I'll tell you what I'm going to do. I'm going to do this. Let's just do this. let's do this. And we could go this way. We could say, okay, AC is equal to CD plus BC. And that's just substitution. Okay. So dig what we did. We took this thing right here. And I took this thing. And I could say, okay, I can replace AB with CD. Okay. Therefore, AC is equal to BD. And let's see. Oh, that's what we were trying to prove. So we're done. Yeah. I got kind of sidetracked there for a minute. But there we have it. And I guess that would be the transitive property, right? Okay. And notice we use the transitive property up here as well. Okay. So BD equals BC plus CD. AC also equals BC plus CD. Therefore, AC must equal BD. AC must equal BD. There, we proved it. Okay. Okay, so these are kind of fun, but they can be exasperating, when you're trying to work through here and know when to start. So don't hesitate if you have any questions. I've got 3 proofs down here that I'd like for you to work on for this section. Okay? All righty.